Alright guys, we're now going to go over the back of the worksheet, the back of your note sheet. This talks about the reciprocals. I know it's been a few days since we did anything with our reciprocal functions, but normally we're used to saying, okay, well if it's cosecant, then that's just 1 over sine. And if it's secant, that's just 1 over cosine. And if it's tangent, that's just, or if it's cotangent, that's just 1 over tangent. The deal with inverses though is that that's not the case. You're not going to take 1 over the inverse of anything. What you're going to do is take the inverse of 1 over whatever that thing was. So let's say, for example, we have something like number 4. If you look at number 4, that's secant inverse. Well, you can't do the inverse of a secant without moving it over to cosine. So you're going to take the inverse cosine of 1 over whatever the number is next to secant. The number is 2, so I'm looking for the inverse cosine of 1/2. So for this top piece, you're just going to use them in a calculator. And I'm okay for the time being with you being able to put them in degree or radian, your choice. Be able to go either way. And when it comes right down to it, if you're trying to do this, it's second whatever your trig function was. So second sine or cosine or tangent on your calculator. So at this point I would say pause the video, plug those into your calculators real quick, and get your answers. Alright, now that you've paused the video and you've done those, I would say if you plugged this into the calculator in degree mode, you got 90 degrees. If you plugged it in the other way, you got a decimal. That decimal should come out to be pi over 2, which, if it's in radians, I will say I will accept decimals only on problems where I say use the calculator. But 90 degrees is pi over 2 radians, so that shouldn't be too difficult to make that jump for. For number 2, if you plug that into the calculator, you got 45 degrees, which if you guys remember in radians, that is pi over 4. In number 3, you got negative 45 degrees, which is negative pi over 4. And for the last one, the inverse cosine of 1/2, you should get 60 degrees, which is pi over 3, if you go to radians. Now, are all of them always going to be those nice perfect degrees that we're used to dealing with? No. Sometimes you're going to end up with really ugly ones that are like 28.75, and that's fine. Just be prepared to know that they're not, with the calculator, always nice. Now, the thing you do have to remember is that your domains are still being held here. You are not going to have an x value above pi over 2 for sine and cosine. You are not going to have an x value below negative pi over 2 for sine and cosine, or for sine and tangent, rather. For cosine, you should be between 0 and pi, and that's it. So, what if I don't want you to use the calculator? If I want you to evaluate these using the 4 trig charts, then real quick I would say sketch your trig charts. 5 degrees, 1, 1, square root of 2. You need your 30 degree, 60 degree. You need your cosine sine chart. And you need, all students take calculus. Alright. If I ask you to use your charts or not the calculator, guaranteed your angles are going to go back to one of these 3 and then you use this chart to determine whether it's positive or negative. So for the first one, the inverse tangent of root 3 over 3. That used to say the inverse tangent of 1 over root 3. That's taking it backwards from its rationalized form. So tangent is opposite over adjacent. So which angle has an opposite being 1 and an adjacent being root 3? You should be saying, well, if the opposite is 1 and the adjacent's root 3, that's got to be a 30-degree angle. And you're right, it is a 30-degree angle, or you could write this as pi over 6. Now for cosecant, inverse cosecant, remember you have to convert that back to inverse sine of 1 over whatever this is, so 1 over negative 2. Please remember, Where is sine negative? Sine is negative down here. Remember from the front that we are only allowed to use these two. So, with that being said, it's got to be in quadrant 1 or 4. Because remember, we can only go from negative pi over 2 to positive pi over 2 for sine. So if it's got to be in these two quadrants, where is sine negative? Quadrant 4. Okay? So, I know my answer is going to be a negative. I know the opposite is 1 and the hypotenuse is 2. Opposite 1, hypotenuse 2, I'm talking a 30-degree angle again. So again, I'm at negative 30 degrees or negative pi over 6. Inverse cosine of root 2 over 2. Recall that this should be 1 over root 2 before I simplified it. So where is the opposite, or the adjacent one and the hypotenuse root 2? That's in the 45 degree. So this makes it a 45 degree angle, or pi over 4. And the last one, where is sine 0? Well, sine is 0 in two places. It is 0 here, and it is 0 here. So that probably would lead you to say, oh, well then it could be 0 or pi. The problem is, remember that sine is limited to only being between negative pi over 2 and positive pi over 2. Same for tangent. And remember cosine is between 0 and pi. So I can't use pi. I can't use this value for sine because sine's stuck between these two quadrants. Somewhere in here. So the only answer I can use is 0. So what I'm going to ask you guys to do is go ahead and plug these into the calculator. The next section, that's 9 through 16, plug those into the calculator. Go ahead and do degrees because it's going to make checking it a whole lot easier. And then the bottom part you're going to evaluate using your trig charts. So I'm going to go ahead and pause the video here. The next video is just going to be me putting up the answers to the next section.